In this tutorial, we are going to conduct a Manova with a discriminant analysis post hoc test. And so you see here the data set we have. The research question is whether a certain types of treatment, those are our groups, either treatment 1, treatment 2, or a control group, have any sort of effect on the outcome on several variables, and all of these variables are related to science, skills, and knowledge. So these treatments are some sort of educational intervention. So the first thing that we're going to do to run our Manova is go to Analyze, General Linear Model, and Multivariate. And then we're going to go ahead and put our groups in for our fixed factors. And that's treatment. We have 3 different treatment groups. And then the rest of our variables, our dependent variables, are all going to go in the other box. Okay, so we're going to go into options. And we want a few things. We want descriptive statistics, estimates of effect size, and we also want homogeneity tests. And we're going to hit continue and OK. So the first thing that you're going to look at is the boxes M. And the boxes M helps test the equality of covariance. And this is one of our assumptions in Manova. And we want this to be a non-significant result, and it is. So we have met that assumption. Now we're going to go down here and look at the actual test statistics. And specifically, we're going to look at these. And we have several different test statistics. But the first thing we need to do is look at Levine's test of equality of error variances. And we want these all to be non-significant, but you see here that actually a couple of them are significant. And so because we may have issues with that, we're not going to look at our Wilks lambda test statistic. Instead, we're going to look at our Pillai's trace test statistic. But really, it doesn't matter because they're both significant anyways. All right, so we know we have significant differences here. And you can see down here that it will actually give you the separate ANOVAs. And you can see that here. But what we really want to do is we want to really find out what those significant differences are. And so this is why we go ahead and run our post hoc discriminant analysis. So we're going to go to Analyze, Classify, and Discriminant. Here we're going to put in our grouping variable, and it actually has us define our grouping variable. And so it's between 1 and 3, right? We have 3 groups. Continue here, put all of our independents in. Okay, and then we want to look at some plots. So we're going to go to Classify, and we want combined group plots. So we're going to hit Continue here and Continue here. All right. So the first thing that you're going to notice is the eigenvalues. And the eigenvalues tell us what percentage of the variance each discriminant function accounts for. So you can see that discriminant function 1 accounts for 65.9% of the variance, and discriminant function 2 accounts for 34.1% of the variance. You can see when you come to your Wilks lambda, it looks at the significance of either both the functions together or just 2, and they are both significant. So we have 2 significant functions here. And so now you're going to look at your standardized canonical discriminant function coefficients, which is this box, and you're also going to look at your structure matrix. And you use these together to see how all the different variables contribute to each discriminant function. So for example, when I look at my structure matrix, I see here that definitions and terminology are significant. They're significant correlations. And so, but then when I'm going to go look up here at definitions and terminology, I see that definitions really is the variable that contributes the most to discriminant function 1. And so because that's the one that contributes the most, and we're looking at different science skills, we're going to give it a name, and we're going to say that this one is content knowledge. So now we're going to look at function 2, and we're going to see here that we have 3 significant contributors. And then we're going to look up here and see, well, how much do they? So inferences is pretty high. application really isn't that high. And problem identification is a little bit higher. And so if you're looking at problem identification and inferences as the two variables that really define this discriminant function, you might name it problem solving. These are names that are made up. We base it on the variables that are in that discriminant function, but you can name them whatever you want. It just helps us conceptualize the functions better. So now we go to look at the group centroids, and this tells us how much each treatment group is related to each of these functions. And so you see here when you look at discriminant function 1, E1 and E2 are pretty highly related here. And they're related to discriminant function 2, but not as much as the control group. So what really helps us understand this is when we come here and look at our combined group plots. And this helps us see how these are all related. So function 1, which remember we said was content knowledge. If we look at function 1, we see that our treatment E2 was better than E1 and the control treatment at helping our participants learn content knowledge. So then let's look at function 2, which we said was problem-solving skills. When we look at problem-solving skills, we see here that E1 and E2 did about the same, but they both did better than the control group. And so that helps us really understand these discriminant functions and helps us understand our overall significant Manova result.